So as we said, we are going to make a level program work with an output on high level. So we're going to go through some of the instructions first and how we go ahead and make a program. We went through some of the changes here last time that need to happen. As you can see, I've changed my IP address back to 192.168.1.5 in keeping the first three digits here. We'll go through how to set up a new controller with an IP address in a later video. I just need to get one. This one already had an IP address in it, and so we'll do a little bit of works on RS links at that time. Excuse me, but as you can see right now, this PLC is running on 192.168.1.5, and we are just going to leave it there. So one of the things that one of the first things we're going to do here is to start programming in ladder. Now, Connected Components Workbench works in ladder, works in function blocks diagram, and it works in structured text. Ladder is the age-old, reliable programming language. Everybody understands it. I grew up on it. There's nothing wrong with function blocks diagrams. I just don't use a ton of them. I don't find that there's any real advantage to using it over ladder. So I'm going to go ahead and under the main tasks here, I am going to add a ladder diagram. Open that up. And the first thing we're going to do is we're going to rename this, and this will be control. Okay. As you can see along the top here, our instructions are all available to us here. The top row is the actual instructions in the submenu. These are the submenus down below here. There are many submenus, and it kicks off with your favorites. So I've been using CCW for quite a while. I have amassed a number of favorites here that I use quite commonly. This is easily done by going to the submenu that you want, finding the command or the instruction that you want, and click adding to favorites. Okay, so that we go back here, and that STOD I put up there appears in my favorites. I right click that, I remove it from my favorites. Okay. Instructions can be added in a few different ways. The easiest is the old drag and drop, just like in Logix 500, Logix 5000. We would go ahead and we would take instructions and we would drop them down onto this row. Okay. Addressing instructions is really simple. We don't actually use addresses per se anymore like we did in Logix 500. Now, if we go and look at our variable selector, which is done by double clicking or looking at controller variables over here on the left, we can see that we have all these variables. Now, when you double click on an instruction, it's going to pull up the variable selector so you can add an address or a variable to the program, and it's going to automatically come up with the data type, which in this case is Boolean. It's on off. All right. If you go into the controller variables over here, and again, all your menus come up here on the top, you will see all of the currently installed variables that the programmer, that the controller comes with. Up top here, you've got your analog ins, like we discussed in the first video, and your analog out, your digital outs, and your digital ins. These simply stand for input, output, embedded module, analog input 0, 0. If you were to add the IF4, it would give you the plugin module. This would say IO, but I think it's PM for plugin module, but as it sits, these are all embedded on the controller, so these are the embedded modules. So your 4 analog ins, your 1 analog out, you've got your digital outs, and then your digital ins. Okay, so we're going to go back to our main program here, and we are going to look at some of the basic instructions and how they're going to work to control our level. So we're actually going to get rid of these right now. Okay, we're gonna delete this. We're gonna delete these. So the first thing that we're going to want to look at is our input scaling. Okay, because we're taking an analog input and we're doing stuff with an analog input. We're going to manipulate it. So you can drag an instruction block down, or if you've got them on the favorites, I'll show you here. Under the, see, I've used the favorites so long here that I forget where half this stuff is. Because I don't know what submenu that's under now. However, if you go up here, I know it's a scaling block. It'll be under process control. That little search bar up there, once you get to know the function block names or the instruction names, is really super handy. So, and a lot of them are hand-me-downs from the old Logix days. Now, you can change, some of these will change depending on the theme. I always work on Logix theme because I grew up in RS Logix, but you can go to the default one, which is the connected components workbench default. But if you're going to be flipping back and forth between programming the micro Logix 1400 in RS Logic 500 and connected components workbench, it's highly recommended you use the Logix theme, right? So if we scroll down here and look for process control, there it is right there, we will find a scaling block. So just add one of those to the scaling block, to the latter one here. So when you hover over the scaling block, or any instruction for that matter, it's going to give you the inputs and the output data types. So here you can see a lot of these are booleans, reals, booleans, unsigned integers. We'll get into all that later. But understanding what data types go where is actually really important. The other thing that you do is you highlight that. You just click on it once, and if you go F1, the help menu, which is built in, pops up, and it gives you the complete instruction book on that particular function block. Tells you all about the data types that you need on each one of these inputs. Keep in mind, you don't necessarily need to assign every input or output every single time. So if you're having problems with an instruction, just pull up the instruction help. It is full, absolutely chock full of useful information. And at the bottom of each help screen, it shows you what it's going to look like in an FBD, in ladder, and in structured text. So minimize that. We're going to go back here and we are going to find an input. Now, there's a couple things we can do here. We can either build our variables first, or we can build them as we go. It's no different than any other program. So in here, just for fun, we're going to go find our analog input 1. Okay. So the other thing to do, by the way, is if we go to our embedded I/O, you can see all of our I/O here on the controller. This obviously gets a lot bigger when you've got some of the microwave 50s and microwave 70s. But if you ever need to know what's going on with your onboard I/O, it's in this section right here. And there's a wealth of information under the level test page. So we'll go back to our control, and we'll also go back to our variables here. So analog input 1, I've got these wired in for analog input 1, and we're just going to call this level transmitter 1. A couple of important notes here. You can't change the name. That's basically the address, and you can create them, and we'll show you that. You can look down here and see the new, and we could create a new address that isn't allowed to have any spaces in it. The alias is basically the device descriptor. You can literally write whatever you want in here, numbers, letters, special characters, whatnot. There's a lot more rules around the name because this is, again, used for actual addressing. So we'll go in here and we'll say our DO is going to be relay 1 high level. And we'll use that later on in the program. Okay. So we're going to go back into control here, and we are going to add an input. So now that we've named that, if you just type in the first letter, it will give you level transmitter 1. Okay. Now, I did this to show you that you actually need to do some conditioning first to level transmitter 1 before you can actually punch it into a scaling block. Because if you go on here, the enable is going to be a Boolean, okay, which is just a 1 or a 0. Does it calculate or does it not? The input is going to be a real number. Now, as you can see, this is a word, and we can't change that. So this is one of the reasons why under my favorites, you'll see store. Okay, so I'm going to add a run here, and I'm going to go back to my favorites. And you can find all these in your own. And I'm going to move store. Oh, no, that's not, that's definitely a scaling block. What we want is a store. So what I'm going to do is I'm actually going to copy this address. I'm going to paste it here. Okay, and then I'm going to create a variable. So you got the upper box, and in the upper box, you can type in the first letter, as I said, of any of the established variables. But if you haven't built that variable yet, or if that address doesn't exist, you have to double click the bottom here. And now, as you can see, it's telling you that we don't have any real variables in the program. And so we are going to create a real data type. Now this you can alter for some crazy reason, but you don't want to. So we're going to rename that. We are going to name this level tx1 real. Okay. Then what we're going to do is we're going to copy that, and we're going to paste it down here, and our error goes away. So there is a few different ways to figure out what your input raw max and what your input raw minimum are going to be. However, the easiest way to do it, I find, is trial and error. If you just stick a multimeter in there. For these, I know that I'm somewhere for a 4 to 20 transmitter with the way we have it configured with the resistors, because I put a 250 ohm resistor from the common to input number 1. I just know from experience, and again, we're going to go back this. Okay, so this wants a real number, which means you're going to add a decimal place to it if you're going to put a real variable in there. And my input raw max is going to be around 2000. Okay, and my input raw min is going to be around 400. And we can work on that scaling later. You can make these HMI configurable. You basically store a variable from the HMI in there, so if your scaling is off, but we'll get to that in future lessons. So the engineering units that we're converting this to is actually going to be pretty simple. We're going to say that it's 100%, and the EU minimum is going to be 0%. Okay, now if we go back in here, we need an output. Okay, so the output is going to be a real number. So we're going to double click on that, and we are going to call that scaled level. Okay, and sometimes I just use the abbreviation SCL. A lot of times I put a lot of shorthand in my programs. Not that hard to figure out. We're going to hit enter twice, and all of a sudden we have a scaled level. So what I'm going to do is I'm going to save that, and I'm going to download it to my controller. I'm going to download the project values. We'll get into starting project values a little bit later when we actually have to deal with things like VFD minimums and all that other kind of thing. Downloads complete. Change controller to remote run to execute the control progress program. Yes, we want to change it to run so that it actually executes the program, and it'll come up with something live. So now I got a bunch of numbers in here, but I have nothing. As you can see, we're about minus 25%, as you'd see in a multimeter, because we're at 0 and 400 is the minimum. So I'm going to go ahead, I'm going to power up the loop to my process meter. Okay. And in doing that, we're going to stitch this in here. And we're going to simulate an output. And now, as you see, we've got 0% level. We've got 4 milliamps coming into our controller. Okay. And now you see we've got 398 counts on our input. Now I'm going to take this up to 20 milliamps. And we've got, we're just shy of 2,000 counts. So the big takeaway from here is that we're looking at it's about 1997 is our max count. And 398 is our minimum count. So what I would do in this event, if we were just doing it without an HMI, I would disconnect. I would change this to 398.0. I would change this to 1997.0. I would save that, and I would download it with those values. Would you like to change to run? Yes, we would. And it'll pop up. And now we actually have somewhere around that 0 level at 398, 398, 399. It's fine. We'll go up to 100%, 20 milliamps. And we're pretty close to that 100%. Okay, we'll move on to the rest of the programming in the subsequent videos.